I've invited Rob Reefman to come from Netherlands to talk about configuration management and in general and his experiences, and he found the curriculum, or maybe parts of the curriculum in the course, and has some ideas about how to relate configuration management to flexibility as I'm teaching it. So, please Rob, yes, okay. Just get started. It's a pleasure having you here.
Yeah, it's an honor to be here for you with this invitation, and I hope you'll find it worthwhile afterwards, but we will see. I was here at NTNU talking about something about configuration management, and I got the invitation from Niels, and he saw importance in it in project flexibility. So my first thought was how to position configuration management and flexibility. So I just used the definitions. Niels wrote in 2016 states, being flexible is characterized by capability to adapt new and different or changing requirements. And my teacher for configuration management, Vincent Guest, he said configuration management is the process of managing organization, product, facilities, assets, processes by managing their requirements, including changes and assuring that the results, in case of a product, the physical object, or in case of a business process, the human behavior, a bit more difficult, but anything, and also for assets, the way they have to handle. Everything is driven by requirements. And in my presentation, a document and a requirement is the same thing. And the idea behind it is somebody has to do something. To do it, he gets a document whatsoever. It's a requirement. If it's not a requirement, he doesn't do anything with it, then it's no worse to having this document. So in this case, document is requirement. So the common thing is change in both in flexibility projects and in configuration management. So first, are we going to have a look, why are we doing it? And that's not only for configuration management or project flexibility. In fact, it's for everything that we do to improve processes. It can be systems engineering, it can be BIM, it can be anything. What is happening in our processes, in life cycles of products, in life cycles of business programs, etc., etc. So, keep the project within budget is a common problem. Delivering according schedule, that are the normal ones. Specific is delivering physical objects conforming their requirements, especially in building and construction. This is a problem. One looks more, is a product suitable, then in opposite, is it fulfilling their requirements. And the big issue, at least in the Netherlands, is the decrease of failure cost. Failure cost is estimated in big numbers, macroscopic, for building projects in Holland, between 10 and 20%. I don't know the numbers in Norway, but it's only on macroscopic level, because inside the projects you have a consortium and they know about all these failure costs, but they say, I'm doing it well, it's your fault and it's your fault. So nothing happened about failure cost. Configuration management is also used in operation, maintain, repair and overhaul, and there we have a specific obstacle. The challenge is keep physical objects conforming requirements. What is in the mindset of people in the asset management, maybe you can correct me if I'm wrong. but you can correct me if I'm wrong, people in the asset management area, they are seeing their problem as keeping the documentation the same as the assets. That's the wrong mindset, because what you need to do is keeping the assets conforming the documents. So there's a real mission to do. If you put it
thing in maintenance management.
If you put it the other way around, if you keep your documents conforming the physical objects, your assets, then you're running always behind the facts. And general number in Holland is that at big plants like electricity generating boards, even nuclear generating boards, chemical plants, only 60% of the information of the documents is reliable and the rest is wrong. So that's a very big problem. And the way the processes I will show will help you to get 100% good requirements on your assets. Okay, another thing to compare the mindset of doing conservation management and the mindset of flexibility projects. For my position, I look to the project efficiency, to avoiding failure cost or avoiding corrective actions. So all negative parts, all things that go wrong, I want to avoid. If you look to the work of Niels, he's looking for the positive sides, adapting to uncertainty, to change, and having in mind everything is good. Only, yeah, there is uncertainty in life and in our projects, how to handle that. So, where we come together, that's I think the license. What we don't want is we don't want to introduce uncertainty by having weak processes. That's where we come together, I think. If you don't agree, just tell me. This is a way of thinking in my preparation of this presentation. Okay, corrective versus flexible. In the way you want to do is you are creating a change, you're creating new requirements, new documents, and then you have to require them to make the product, and that gives you the results. What you have in a positive, flexible or continuous improvement loop, that's the outside line. This is, if you have the right processes, you have a closed loop without gaps that are filled in by all kinds of individual actions and all kinds of exchanging information. Now you have a very closed process. We will see later. And in most business, in a normal loop, you are creating a change. It's not really good organized, and along a fuzzy loop, things come into a database, probably not reliable. It's difficult to get the last version. It's you find the same identifications for different requirements, etc., etc., and you get confusing applications, and the results will give you all kinds of failures at unexpected maintenance, which have to be in rework and corrective action. You have to do it good. And about the number, the man I mentioned, Vincent Guest, did a measurement in the States, and he came to the conclusion that 40 to 60% of an engineer's time he is intervening in work that didn't go the first time well. I repeated this measurement in a little bit another way on a Dutch shipyard, and it was more or less confirmed. So there's an awful lot to earn in the design and engineering process. Okay, I think that the root cause for failures is I will repeat it, is flawed documents in the process. That's the bottom line of all mistakes and errors. Still have to prove that in research, but that's what I think. And the general objective of configuration management is to get good requirements, good documents, and to keep them in the case of change. And important causes for getting flawed documents is, one point is very important, is open ends in an offer or in the contract at the beginning of a project. It's caused by inadequate validation processes and also inadequate way of changing. Most companies have a lot of change processes. If there are changes, then priorities are very often determined by the most assertive persons in the game and not by the real project priorities. So that's a point as well. The other thing which is very important, to keep the physical objects conforming their requirements. And you should do that by an adequate verification process. And especially if you look to building and construction, there is no good verification process. As the product is usable, is suitable, it's okay. And faults are coming. Now I'm talking about the Dutch situation, so I don't want to excuse the knowing one. But things come up, safety issues, balconies coming down, structures of buildings that are not good. People have to move so they can wait 2 months in a hotel so they can repair the construction, etc. So all this kind of heavy things we want to avoid. And I think also a policy change is needed. And the policy change we need is like in aerospace. In aerospace, it's right from the beginning. Every product has to be conform the documents, the drawings, etc. And in building and construction, who cares? Little bit exaggerated, but so in first you need to change the policy, the same policy. Every product you make must conform their requirements. If not, you have to verify that. If not, you need to take an action. Either you rework the product, either you change the document. And to make people a little bit angry or react, I say to people in asset management and management and repair, as long as you talk about as built, it will never be a good process, because the term as built as a word implies that you accept non-conformances. That's the difference between as designed as required and as built. But the policy should be, don't accept non-conformances. That's the only way to get and keep your documentation up to date during the whole life cycle. Okay, again, this is the Netherlands. What do I see during the last 4 or 5 years? There are all kinds of nice enablers coming, like building information model, with a lot of expectations, etc. There are also some other improvements in building and construction. But if you look to the macroscopic Dutch level, whatever it means, the failure costs are not even decreasing, but slightly going up, perhaps because the projects are a bit more complex. That means that all our tools putting into the market doesn't help quite much. The other thing I react to is looking to the world of building information models, they are treated as one single model and being released as one single model. In my view, from world I come, I think this is quite impossible, because this building information model is existing out of objects with each their own life cycle. So if you have one thing with internally a lot of objects with different life cycle, how can you release it in one single part? So my conclusion on that was, this indicates a bad control process. And that's the reason I entered in this. I saw it as a challenge. I entered in this world of building and construction, because there's the most to do.
First of all, could you say a few words about your background?
Yeah.
In the aerospace industry and how
Yeah.
you got
Okay,
inspiration to
very
transform?
fast. There's one single line in my life that is what is called product lifecycle management. But I started as an electrical engineer, high voltage, high current. Even my first application, it didn't work out, but was at the Elektricitätsforschungsinstitute here. So I'm building with a locomotive in front. I don't know it's existing. I'm talking about 1970, so I don't know. But from the electricity world, I was involved in the development of vacuum circuit breakers, and I did all kinds of calculations for the development. I used the program Nastran, not for mechanical things, but for heat, for electrical fields, magnetical fields, all that kind of stuff. And from there I went to the introduction of CAD systems. That was the end of the 70s, early 80s. Then the electrical company where I was working for went bankrupt, so I had to leave, and by my network I came into to Fokker, the space department, and I was doing a kind of dual project about the CIA computer-aided engineering in European space world. So that was collecting information and writing reports, and was not that. And then I got a function at the aircraft site, and that was how you call it? A coordinator for all geometry systems, from design until the manufacturing. And so there I came in this world from PLM. At that time it was EDM and PDM and whatsoever. And Fokker went down as well, so I moved to a computer company for CAD systems and PDM systems. That was end of the 80s, and that was computer vision. Later on bought by PTC, and there I worked with this kind of systems, ending in the Relational package. And I was a program manager for the European aerospace, and that was a beautiful time, and I learned a lot. I was child at home at most European aircraft manufacturers, from Saab to Airbus to CASA to Air Italia, and the 3D work I learned most from the, you won't guess it, but it were the Italians, the people in Turin who were responsible for the development of the European airfighter, their systems. And then this computer firma went down as well. So I worked for them in Brussels in an international environment. So I came back to Holland, and I thought I know so much about integral product, about BIM. I saw at the end of the 80s a super BIM, completely controlled with structure under a PDM system, and it could at that time do more as BIM at this moment in time. So I thought I do so much, it's easy to get a nice job again. but that was not possible. So at that moment I started for myself, not because I wanted so much, but because it was the only possibility left. And I came at that time already in contact with parties in building and construction. I got a bunch of money to introduce at one company or a consortium a BIM, like we talked about. At that time I called it Integral Product Model, IPM, and that failed because one of the partners in the consortium wanted to do it with AutoCAD and on a Windows system, and I'm talking about '94, so that was impossible. So, and I was too naive, thinking that on my own I could do things that cost millions of guilders. So that was, and then I started with a colleague, another company, thinking about these PLM systems are so cost that much that we buy a system and we offer services to projects, and we will be a bank for your product data. So we called the firma ERO, then product data bank. We got a lot of compliments for the business model, but it never worked. We were too early, and I was saved by the bell. We got a few orders from Airbus, and that saved us because that were the good years. They hired us for 2 months and it became 8 years. So that was good. Then Airbus went changing, reorganizing, and I was back to my own. My good people were bought away all about the same time. And then I was 65 and said, okay, no more personal. I just go on myself, and with contact here and there, I do something on that side. I came in contact with universities. I met Nita Maun in Reykjavik, where I did a presentation on this in combination with knowledge management. And via versa, I'm standing here. So a lot of years in small thing. But the work has always been fun. Okay, get control process. More generic problems. And a lot of the same. I go to the downstairs ones, building and construction projects with a lot of parties. Everybody has double agendas, and it is not that transparent, and that gives a lot of irritation between partners and also to the client. And the point is that nowadays parties discover this is not the way of working, and getting transparent also brings a lot. Getting transparent means also that in a consortium the risk and uncertainties are not calculated double by each party and overlapping, but if you be honest to each other, the parties, the same risk they can put under the same calculation, and this openness will also save, it's a Dutch experience, about 10% of the projections. I already discussed serious safety problems, and sometimes I leave the last part out, depends for whom I talk, and sometimes I put it in. Because I think, and Neil told me it's the same in Norway, if you have the contracts not defined too well, then you say to the customer when he wants something else, okay, that's additional work, that means he has already the order, that means additional revenues, and especially additional margins. So, but if you say that to the people itself, that's not so. But that's practice. I think it's still more or less, and I think it moved out because there comes more pressure on the sector to be transparent, to be clear, to get your requirements right from the beginning. And if you do professional configuration management, you are building in transparency. So depending on the number of parties, or they like it or not. Okay, this was so far we were looking top down. What are the problems from the management with all these projects? But there's one big, important place where the work is done. And if I say that I think that the documents, flow documents, are the main reason for failure costs, then we have to look to the floor. The engineers are working, they have to produce the documents, the requirements, they get orders, hopefully written orders, and not telling you what to do and so on. But if you have no written orders, I don't know how to get a good process. So written orders, and one order ought to reference all the needed documents, all the needed input documents, what is needed to do the job. And all these documents, all these requirements need to be good. And what good means, I will explain later. And these engineers, either they will produce another requirement, another document down the line, or they make a physical part. And they use tools, they use libraries and procedures. And what is the problem here? Missing documents. If an engineer sees that he's missing documents, he goes and look for them, waste of time. But it's also possible that he doesn't see it and he misses a gap between what is in the input documents, and he will find a solution for himself. And he can come up with an excellent solution, but an excellent solution, if it's not requested, is also costing money. The same problem, I saw a lot of non-consistent documents. For example, the shipyard I was, the sales talks to the customer, and on one big drawing there was a door which swings to the right. On another document, the door swings to the other side. So it's not that important, but probably it happened because documents were released, while other documents that had to be changed as well were not changed. So, and this happens. It's a simple example, but this happens a lot. And I will use the word consistent. Will come more often in this presentation. The other thing, non-clear documents. Non-clear means very strictly non-clear for the user. It might be very clear for the one who is making the documents, but it's not clear for the user that has to do a job. And again, he might ask. Then he not only he wastes time, but we are all nice guys in the factory. If somebody asks us something, we go to work to find the answers. If one engineer asks something, he may generate a lot of work, not visible in the rest of the company. I have seen non-valid documents working this. Documents not even released. Documents that were given to another to ask for an opinion. And what happened is that not an opinion was given, but there was made a total evaluation, or it was good enough, strange enough, etc. So a lot of work done, there was not any ask for. Okay, as a consequence of this, you will lose a lot of the quality in the projects. Most of all, the results doesn't meet specs, and yeah, in a way of working you don't care that much. It might be not that, but anyhow it's not good, and you never know what it will cost you, and you lose lots of money and time, which is not always accountable for, because what you don't see and doesn't hurt, and you are accustomed to giving a lot of money for a certain work, and the Dutch contractors, they are very proud of their improvisation. They always make a good product, but at what cost? Okay, I already said that, so I have to prove all this, so I hope I can put this somewhere in the research. Maybe you are interested to pick some of these things up. But I think the main root cause for failure is flawed documents. And the main root cause for flawed documents is weak process management, weak processes. And I think still have to prove, but I hope you are convinced after the presentation that to keep and create good documents, we need configuration management. A lot of improvements in Holland and a lot of improvement proposals are based on the soft side of an organization, better communication, shorter lines, etc. And I think you should do that, but if it's only effective is if the foundation are good documents, and if you only start nice communication and meeting schemes, etc., etc., if the documents are not good, what does it bring you? Problems are still the same. Okay, the research I'm seeing, so it's design and implementation of a fully controlled design engineering process, and the realization it is minimum quality cost. Very important are measurements. I think you need to measure at least the degrees of throughput time and the degrees of quality cost. And with quality cost, I think quality costs are all failure costs and all costs you make to prevent these failures. And I've been educated in a Six Sigma environment, and one of the big lessons there is always an improvement project should always contain a financial target for savings and a measurable contribution to your strategic objectives. Does it make sense when you start a project to ask the management what are your strategic objectives and how do you measure them, etc. You will be surprised about the answers. No. Many times you get answers. You have from the management. Okay, we have them. You have to look in our quality system. And that was one. So there is something, but you have a big chance that they put them there, because if they were not there, they didn't get the auditor signed their certificate. So there's a lot to do as well. It's not technical. Okay, possible solutions for large public projects. It comes into Holland. In America, it's right. It's rather popular. It's what they call a relational contract. So more transparency, more discussion together. What do we want to do together, etc. And it's called. You can look that in Google. It's called IPD, Integral Project Delivery, and there's a whole concept behind it. Big public projects in Holland, they try to improve by centralization and shorter management lines, transparency and mutual trust. I talked about. I'm concentrating on the process management, on the optimum use of the available knowledge in the project, and yeah, more or less systems engineering as well, but I'm really focusing on the red ones. Okay, this is very short, so Niels, I just had time to go quickly over his thesis and what he is learning new. I think on the other slide, flexible projects can be added, but the relation and where it has to stand, I have no answer for that yet, but it belongs somewhere in the same row, and maybe I can make it red overnight also as well.
I would see configuration management at least as an enabler for flexibility, for this type of kind of positive value-added flexibility, and as a tool to reduce the failure and non-productive iterations.
Okay, expected long-term results. Decrease of failure cost with 75%, increase of productivity of design engineering with 100%. Now, you ought to be laughing, that's nice, but how? I tell you where it comes from. From Six Sigma, in looking into manufacturing. They are telling quite generally as their experience number that from everything what goes wrong in realization, in manufacturing plants, etc., 70 to 80% is coming from design and engineering. So from there I say, if you have your design and engineering in the right processes, you will earn this amount of money from the total process. That's where it comes from. And it's not that it's absolutely true, but that gives you a road in what situation you want to work and where you are looking for your results. The same thing I I mentioned this investigation of Vincent Guest telling us that an average American engineer is spending 50 to 60%, say half of it, easy 50% of his time in intervening in things that went the first time wrong. If this is true, and you can use configuration management to get closed loop processes without caps and all kinds of fuzzy things, then you should be able to increase the productivity of engineering and design engineering by 100% there. So this is only a road to heading for, and it's good in agreement. Is good in agreement with what I heard yesterday. There's a setup of a new Norwegian project called Speed Up. They want to improve. They say, okay, we want to improve everything at least double. So it fits real in totally another approach, but the numbers where to go are about the same. And we came up with a kind of, what should we call it, flexibility without all this corrective action. Should be kind of balanced flexibility, how to define it or whatsoever. I don't know if to argue to study that. Knowledge management. I don't go into deep in it. The knowledge is inside. This is the knowledge. It's inside people. It means for a company, knowledge comes in the morning and goes out in the evening, and eventually knowledge walks out of the door forever. The only permanent knowledge left for the company, that is the knowledge that is called explicit knowledge. That's knowledge that is get out of the heads into requirements, into documents. For a product, it's about to know what, and for a business configuration, you will see that it's the know-how. And and gurus on this field say, okay, we saw this picture of the engineer having his order and having his input document. And my opinion, before I knew something about this, my opinion was, if you have these good documents, then everything is alright. You get the good results. But now, in literature, I found on several places that whatever you do, if someone has to do something, he gets a lot of input documents, the result that he creates is still 85% depending on what he has here and not on the input documents. Yeah, that might undermine my complete story, but I don't know that yet. But the point is, these are questions that have to be included in the research project. At the moment, I'm still going on. It's obligatory that the documents are good, and if the documents are not good, this 85% is useless as well. It might not be true, but we will see in future. Next, part 2. I think I call part 2 is just a quick look over configuration management, and in part 3 I go into more detail. And I suggest it's 5 to 2. I suggest that I run a little bit faster on part 2 and save part 3 for after the break. Okay to you? Okay. Configuration. What is a configuration? In fact, it's the architecture from the product. Many times it's given. There are alternatives, but normally it's given in the form of a tree. And the tree is in fact the items, the composition of the items in the way it is built. You can do it in a lot of ways, but on the same tree they're building it in the way it's built. And to this, in this architecture, you link all the documents to the related object or item. You see these little dots. That's the configuration. And you put here in all the documents defining building construction, for operation, maintenance, repair. Every document has to come in this thing. And we can construct a business configuration which looks similar. And this is the thing we need to manage. Okay, it's about time to explain what do we define good for a document. And there are these points. It's clear to the user of the document. So if someone prepares a document, he should know the users, and the documents should explicitly made for the user that's clear. He has to understand what he has to do. It should be concise. It's a rather general word. I understand it by, I explain by concise is it should be, there's only one interpretation possible, not multi-interpretable. Welcome. And I added to it consistent. These clear to its user, concise and valid. That comes from the big maestro Vincent Guest. I found, later I will repeat it many times, I found consistent very, very important. Because we saw this configuration, we saw this structure. If you change something down the line, it should be consistent with all the documents, etc. Valid. Valid is meaning two things. Valid means that if you follow the document literally, it will lead you to a result that really was wanted. That's one thing, and therefore it's needed that it is judged by experts, we come later to that. The other meaning of valid is that it is authorized. It's very important because if a document is controlled, it's judged. For example, an expert say the strength is good enough or not, it has to be seen, etc. They are all experts. They have no right to accept it for the legal things of the company. The company or the consortium should accept it, so it should be authorized. And I saw a lot of, especially engineering and engineering construction departments, that maybe you recognize it. Somebody comes on with a bunch of drawings. Please, can you sign it because they have to go out tonight and the boss is not here and so on. So also you see, I saw drawings with 10 to 15 signatures. Now that's crazy as well because nobody looks carefully to it. Everybody's saying, okay, he saw it as well, and so look at the mess. So all these type of things has to be settled. So now we know what's a good document. Questions about the good document? Okay. Configuration management has 4 cornerstones. It's the first is the database or a repository. The second is to get good documents, a release process or validation process, ending in the authorization. The third cornerstone is the change process. And the other one, a very important one, sometimes not even existing, is the verification process to assure that the object we are realizing that it's conform its requirements. It has to be there. Or you do it statistically or you control everything, that's not a story, but you have to do it. Cornerstone 1, the database. Very important thing is, and I think almost every company ignores its importance, is data integrity. In the company you use many times a database in series. And if you have the chance on that the document, the requirement is not good, and it's only 8% that something is wrong. If you have 8 steps, you have a trustworthy for that document of 50%. So that goes very steeply down. And first I thought, if you make 2, 3 steps, that's already much, but that's not true. You can look into it. Many times you make much steps in with data in the company. So data integrity is a point. Things need to be good, and any document is good and therefore can be used and leads to a specific result. Okay, that's what I already said. What I put here just for fun, we go further with product. I have here a business configuration. And business configuration with effect the know-how. You see here mission, a strategic plan, organization policy, operating plans. This was made when I was working for knowledge management to put it in such a ring. We have operating standards, we have enabling tools, and we have supporting procedures. All of them are described with documents, with requirements for operating plans, and so on, and so on, and so on. And every level here is in fact requirements for the level under it. And what in fact operating standards, processes, etc. Process in operating standards. What we see here is the ISO 9001, the management system. They are sitting here. And there is a standard called ISO 55,000. It was the earlier PAS 55, which is standard for chemical plants, that type of things. And it's one of the things it contains is that they say everything, every document in this structure has to be consistent with other ones. And then they say,
I wonder if we should take a break until 1:15, or if you just finish.
I like to finish this one. I make a little bit more hurry. I like to finish. Anyhow, they even the big standards, and because they say if you need a structure, and you need to have consistency between the whole system. In fact, you can this see as a total quality system. And the next sentence they all say you need document management systems. And I tell you, document system management, even if all the gurus say so, it won't help you. And why doesn't document system don't help you? That's because a document system is managing single documents. They have nothing. If you change this, they have looking to all this. Who may have access to it? Where is it? Nothing tells you if you want to change document, which documents have to change as well. Therefore, you need configuration management. And that's an extra statement I make, because all the others say document management system, and then they stop. And if I say it doesn't help you, every court better get angry, but it won't help you.
Excellent point. That's very important.
Yeah, I think, and that's the reason that I'm trying to get the word consistent in the definition of good. Vincent Des, he published a book last year, and he came up with a better configuration for the business system. Now you can read it, so it's just this is just for fun. You can do the same. Okay, the cornerstone theory, that's the validation process. We see, oh, that was not the. We shall go quickly, we do it in the detail later. The first thing in practice, building construction, maybe you can confirm that to me. You have the situation that a document is in draft and the document is final. And when it is final, it's not allowed to go back to draft. This is not a life cycle. It's not enough. It won't help you to make a good release process. I'm talking very black and white, but that brings the message, because this is general. But because it is general, it doesn't mean that it's good. I want to see back at least three things. Something is being created, it is judged by experts, and it has to be released. The other things I will talk about later. But any life cycle for a requirement, I want to see at least these three back. That means that there is a mission to do in building and construction, because you have to rearrange the whole way of thinking. And I will tell later there's one thing I can tell you now. You have experience in drawings, in giving drawings to somebody else, etc. Imagine you have a complex drawing and or BIM or whatever, and something needs to be changed, rather complex. You don't want to end up with revision that's too much. So what do? You have a drawing, you make your changes, what you think is good, and I give it to you and ask, what do you think about it? Because I need some advice. I go further, end of the afternoon, I give it to you. Same thing. At this moment, I have already two unidentified objects into drawings into the project, and this is happening a lot. So and then the worst thing I have seen that somebody took such a drawing, not even released, and was already going shopping. Okay, so we need to do something like this. Cornerstone 3, the change process. Here we see that, in fact, configuration management is an eyeglass process. You see here two circles. In fact, both are dimming circles. You study study, act, plan, do. Yeah, that's it. You see it here back. Since as you study, you're making a technical proposal, you decide. And what we see here is that the technical solution, the technical answer, and the management decision are separated. It's decision. And you see after the management decision, yes or no, and if yes with a priority, it goes into the planning, and then the execution. There will be a validation and release, and the electronics goes back in the system. You cannot send every decision through the management board. You have a short circuit for changes with less impact on everything, and for administration reasons you put a lot of small ones to the big ones, so you can trace everything back. But this is then a fast track with some other things. But in fact, you have the same loop for all changes, and not multiple change processes with multiple people who have decisions about it. On the other hand, we see the building cycle. There's a work authorization. We build the object, we verify, and if it's conform, it's okay. If not, then we have to do an action in this circle. I think, yeah, we talked about this too. Oh, I think we go the wrong way. We talked about it. One thing regarding product configuration, the outcome is a product which should conform. The verification on the business side is human behavior, with all complexity as well. Okay, I hope you survived. Can we have a 10 minutes enough for right now?